Hey everyone, I hope you have been all safe and well. Welcome to our first Algebra 1 remote learning video lesson. So excited. Y'all ready? Anyways, I'm your host teacher, Ms. Fu, until we get back to school. Hopefully it's sooner than later. Remember that this is a video though, so if you need to stop and go back, you have the ability to do so. Before we do anything else though, make sure you have a notebook and a pen or pencil to take some notes down, okay? We are starting a brand new unit called Systems of Equations. I know how excited you all are and in love about equations, and that you'll be thrilled to know that there is a whole system of them, right? So let's jump right into it. Today, our aim is going to be how can we identify solutions for a system of equations? And as you can see, system of equations, we could talk about these dogs and cats down here, right? But our objectives at the completion of this lesson, I want to make sure that you are able to state the solution from a system of linear equations, describe the solution to a system of linear equations as well, and then homework. This is going to be your first virtual homework. You need to upload a picture of your notes and completed practice problems after the end of you seeing this video. Cool? All right. All right. So what is a system of equations? It is two or more equations that contain the same variables. So if you notice here, we have two equations. The first equation says 3r plus 6t is equal to 17. My second equation, let me write that, that's my first. My second equation says 5r minus 4t is equal to 18. If you notice, both equations have the same variables, which are r and t. We got a system. That's it. All right. So moving on, let's get started. When we are solving for a system of equations, we are looking for a solution. And that's a point that is in both solutions or all the original equations. It is the point where the line intersects. So we have two lines here. We have y is equal to 1/2 x plus 2. And we also have y is equal to negative x plus 5. When we have these two equations on a graph, we have a system of equations once again because it's two or more equations that contain the same variables. These two equations intersect at this point right here. This is what we call a solution. In order to identify the solution, we just want to identify this point as well. For those of us that are having a little bit of trouble on identifying how to find points on a graph, we always go along our x-axis first and then our y. So for this point, we will go 1, 2 for our x, so that's 2, comma, and then 1, 2, 3, my y value. So in this case, my solution is 2, comma, 3. All right, so take a moment and see if you could figure out what the solution for each of these systems are, and then come back and check your answers. So at this time, I would like you to pause the video, take about a minute or two, identify the solutions, and then come back. All right, so for our first system of equations, the solution is here, and that is 3, comma, negative 2. So the solution for my first equation is 3, negative 2. My second equation, system of equations, falls here, and that coordinate is 2 and up 2. So that solution is 2, comma 2. Right? Now, what's going on with this equation, system of equations here? we don't see that they ever meet. So is there a solution? In this case, because the lines do not cross each other, there is no solution to this system of equations. Yes, that can happen. No solution. All right. And for our last system of equation, our lines intersect at this point, which is -1, -1. Now, if you were able to get all 4 of these right, you are on the right track. Good job, guys. All right, moving on. Now we have to identify whether or not the points that are given is a solution to the system. So we have 2 points that we need to determine whether they fall within this system of equations. All right? So in order to do that, oh no. In order to do that, my apologies, guys. Teachers make mistakes. Check it out. All right? In order to do that, we now need to plug in these points to see if they check out for both solutions. So remember, when we write an ordered pair, it is in the format of x, comma, y. So in this case, x is represented by 2 and y is represented by 1. So I'm going to rewrite my equation. So I have 2 times x, which is now 2, plus 4 times y, which is now 1. Does it equal to 8? 2 times 2 is 4. 4 plus 4 is equal to 8. And in this case, 8 equals 8. So this checks out. But now we also have to check to see if 2 comma 1 works for 3x plus 4y equal to 12. So now I have to do 3 times x, which is still 2, plus 4 times y, which is still 1. Does it equal 12? 3 times 2 is 6. 4 times 1 is 4. And does it equal to 12? 6 plus 4 is 10, but 10 does not equal to 12. So this is not a point in the system of equations. So let's try the next one. Once again, the first term in an ordered pair is x and then y. So now again, we're going to do it again. So we have 2 times 4 plus 4 times 0. Does it equal 8? 2 times 4 is 8. 4 times 0 is 0, equal to 8. 8 plus 0 is 8, and 8 is equal to 8, so that checks out. We got to do the other one again with the 3x plus 4y equal to 12. So we have 3 times 4 plus 4 times 0. Does it equal 12? 3 times 4 is 12. 4 times 0 is 0, equal to 12. 12 plus 0 is 12. And guess what, guys? This one checks out also. So 4 comma 0 is a solution to this system. Pause the video again when you get to this page right here and see if you can figure it out. take about 2 minutes or so and come back. All right. So which one did you guys think it was? Do you think A works? Do you think B works? Do you think both works? Let's find out. We have X comma Y. So we have 2 times 3 minus 8 times 5 equal to negative 34. 2 times 3 is 6, minus 8 times 4, which is 40, equal to negative 34. 6 minus 40 is negative 34, and negative 34 equals negative 34. Check, check. Got to do the other one. Four times 3 plus 5 times, whoopsie, mistake. 5 times 5 equal to 37. 4 times 3 is 12, plus 5 times 5 is 25. Does it equal 37? And 37 equals 37. Check, check. 3, 5 works out for me. Hope it worked out for you. All right, let's try this second set of point. So we have 2 times negative 1 minus 8 times 4. Does it equal negative 34? This is negative 32 minus 8 times 4, which is 32, equal to negative 34. Negative 34 equal to negative 34. This one checks out. Then we have 4 times negative 1 plus 5 times 4 equal to 37. This is negative 4 plus 5 times 4, which is 20, equal to 37. This gives me 16 equal to 37, and 16 does not equal to 37. So if you were able to get these, I'm very proud of you at this point. If not, just take your time, go back through the video and see if you could understand a little bit better. But keep in mind, we also have office hours, so you could always have questions then, and we could talk to you directly. So next, what I want you guys to do is, when you go back to Google Classroom, click on the attachment and complete all the practice problems. Don't forget, make sure you upload them with your notes. See you soon. Bye.